Okay, it says let f be the continuous function. Slow down here. F. This is f. Good. Okay, f is continuous. Sometimes I need that, sometimes I don't. Whose graph consisting of 3 line segments and a semicircle. Okay, I don't really need any of that. Let's cross some stuff off here. Don't need this. I can see that that's the graph. They give me a formula for g. I've seen this kind of thing previously. G is an integral of f. Find the values of g of 2, g of negative 2. So I use my formula for g. Plug my x equal 2 into my integral for f. So I'm integrating from 1 to 2 on f. So here's f. Start at 1. Go to 2. I'm integrating f. And this says dt, which is the horizontal. So if I can find this area, that area is below the axis, the horizontal axis. So whatever that area is, if I count it as a negative number, that will give me the value of this integral. So this point here, I gotta find this dimension here. This dimension. Well, this line is going over 1, 2, and it's going down 1. See, because it's going from 1 to 3, that's over 2 and down 1. Over 2, down 1. So if I go over 1, I have to go down a half. So this dimension right here, in blue, this dimension is 1/2. The purple dimension is 1. So I've got a triangle. One side is 1, the other side is 1/2. Take half of it because the area will be half of that dimension. I count it negatively. If you had the red box, you get a point. You don't have to go all the way to 1/4, negative 1/4. Then for the g of negative 2, same idea. I'm going to integrate from 1 to negative 2 of f. But I don't like integrating backwards, so I switch the limits. And I multiply by negative 1. So now I come over here. Let's clear that off again. So I'm integrating from negative 2 now to 1. So negative 2 all the way to 1. Which means I must count this area as a positive value. And I must count this area as a negative value. Okay, this triangle is 3 high and it's 1 wide. So that's what I wrote down. Here's the negative 1 because I switched the limits. And I've got a triangle, so 1/2. The height is 3. The width is 1. That counts positively because it is above the x-axis. Now the semicircle has to count negatively. That's what the negative 1 is for. And then I memorized from the golden notes that the area of a semicircle is always pi over 8 multiplied by the diameter squared. The diameter is here. That diameter is 2. I don't need to go any further. That would get me the point, showing that information in the green box. 2 total points on part A.